This presentation is of the new phono preamplifiers from Phaedrus Audio and the launch of Stereolab version 4. So for several years our main preamplifier offerings have been the Groove Sleuth 2 and the Groove Sleuth Micro, and those changed this year to the Flux AI and the Groove Sleuth solution. And both these products have been designed to coincide with the launch of the Stereolab version 4, which is now available from Apple's App Store. Just a note that the Groove Sleuth adapters are still on the price list. Both these new preamplifiers use the USB power, so that means you can power them from your laptop, from a little plug-top power supply, or indeed from a linear power supply. Why have we done this? Well, there's less clutter, less power, less waste, and a very tidy working space, a tidy desktop. And how have we done it? Well, portable and wearable technology has produced some really fantastic low voltage, low power electronics in the last few years, as well as advanced PSU design, and we've been able to take advantage of this in the new preamplifiers. The load on the USB is very light with both these preamplifiers, and they can be powered from USB 1, 2 or 3 ports. We mentioned the low noise DC supplies. These are available from multiple vendors. There's an example of one opened up on the left there, which shows that it's got a very high quality transformer. It's a fully linear power supply, and they're available at a very reasonable cost. An alternative to keep away from mains power completely is to use a USB power bank. Obviously that's useful for work in the field, for example, where you don't have access to mains. So the Groove Sleuth AI has options for moving coil, moving magnet for flux, and also the displacement carts, the strain gauge and our own displacement cart. It's also available as a standalone needle drop solution with an internal sound card. It has a unique bridge circuit, which we'll come to later, and a classic output stage. Again, we'll come onto that later, and something called the Seagate supercapacitor PSU upgrade. On the other hand, the Groove Sleuth solution is multifunction. What they both have in common is inputs and outputs, just like any other preamplifier, but in addition to that, they have a sound card output. Now that's the non-equalized output for recording needle drops that can be processed in software later, including the equalization. In the case of the Flux AI, there's also a digital USB output if the internal sound card is fitted. And that enables you to use it with all sorts of software, but we're obviously particularly partial to our own software, Stereolab, with our partner Spatial Audio, and that it's a high resolution audio app for collectors, sound, film and TV engineers and audiophiles. It offers equalization, noise reduction and wide reduce for a wide range of media, from cylinders to shellac discs to analog tapes to film soundtracks. So let's look first at the Groove Sleuth solution preamplifier. This is a universal tool for vinylistas. We like to think of it as the Swiss Army knife, and this is the 7 configurations that are possible. So obviously it can work as RAAA preamp for moving coil, moving magnet, and for flux, and those are those 3 configurations here. It can work as a flux adapter with the switches set as they are here. What's that? Well, that enables you to connect a flux cartridge, which requires phantom power, to a standard moving magnet, or in actually a moving coil input. The preamplifier will automatically detect that it's got a moving coil input, and it will adjust the level automatically. And an incentive to buy the preamplifier here is that if it's bought with a flux cart, it's available at half price. Further applications are a moving coil to moving magnet step-up configuration, and the last one is a moving magnet and a moving coil through. Well, you may say, well, what possible use is that? The cartridge comes in and the cartridge signal goes out. But of course, the reason we do this is that you have the sound card output. So you can install this, you can set it to snoop on your existing setup and deliver a non-equalized signal to the computer sound card. Just a quick look at the functional diagram. So here we have the main, that's the non-equalizing part of the circuit, with the preamplifier for moving coil, which is selected by that switch. There's a ability to change the input impedance from a high impedance to 100 ohms. This switches the phantom power, and this enables the output to either be RIAA or the loop through. So here's a little example of how it might be used. So signal from the turntable comes in here and goes out RIAA to the monitoring system, and the stereo jack feeds the sound card. So let's now look at the Flux AI preamplifier. Now the starting point for the Flux AI were actually classic moving magnet cartridges. And for many years, serious archivists have known that moving magnet cartridges are superior in terms of their tracking ability. An example of this is the sound archivists at the American Library of Congress, who considered the tracking performance of Shaw's V15 so highly that they purchased all the remaining stock of the V15 line from Shaw in 2009 when the manufacturer stopped making this cartridge. And we had a request from a customer, which was we want the performance of the Flux cartridges with excellent frequency response and low noise, but we want to be able to use our preferred cartridge type for archive. For those customers who have beloved moving magnet cartridges, we developed the bridge-based preamplifier. Let's look at the original Wheatstone bridge. This was developed in the middle of the 19th century by Sir Charles Wheatstone, and the explanation of this is given in any electronics textbook. But the important things to remember is that the bridge is in balance when RB equals RA and RX equals RC. And when that happens, this point here, S, and point Q are at the same potential, and any current galvanometer falls to zero. That's the only thing to remember about it. Now, about 30 years after Wheatstone, Maxwell, James Clerk Maxwell, he of the equations, developed an AC version of the bridge which balances impedances instead of DC resistances. So if we imagine the cartridge as a pure Faraday generator, so that's the component within the cartridge developing the voltage that we actually want. To that we have to add the impedances, its internal impedances, so both resistance and inductance, caused by all those many turns of wire. And we have to terminate that at the preamplifier. So this is the typical 47K resistor, which is available in almost all preamplifiers, and a certain amount of capacitance due to the cable. Now if we add matching inductances and redraw and rotate, we've got a Maxwell bridge, which we can redraw like that. Now cartridge inductance and cartridge resistance is shown as that leg of the bridge, and the termination as leg of the bridge. And remembering that the Q point Q is actually our preamplifier input. Now, provided we generate internal impedances to match those external impedances, we can balance the bridge. Now, actually, this is of interest, but it's of little practical use because point P doesn't really exist in reality. The generator voltage, EG, is developed across the cartridge impedance. It isn't actually a real place. It's a real point. And even if it was, we wouldn't be able to get to it. It's inside the cartridge. But imagine if we set up a circuit like this, where a high gain operation amplifier has its two inputs connected to point Q, that's the input, and to our internal point S. Now, a high gain amplifier has the characteristic that because it has such high gain, it has very little potential between its two inputs. And when that happens, point P prime, the internal point P prime, must be the same potential as point P. So, which means we can recover the original EG between point P and earth, which is R, which is the bottom end of the termination input to the preamplifier. And that's the principle behind the bridge balance preamplifier. Now this was very successful, and we ended up with a happy customer who told us we wanted the advantages of the Flux cartridge, but we have a policy to use the Shaw V15 for archiving. With the Flux AI we get low noise level and extended bandwidth of the Flux cartridge using our precious Shaw cartridges in our preferred head shells. Now, I don't want to give the impression that it's just a bridge preamplifier. It's true that the Flux AI has this bridge mode for MM, but it also has a very low noise moving coil input. It supports displacement cartridges if that's required, so strain gauge or our own displacement type, and it supports also the flux cartridges. The MC input is based on our phoneme preamp, which we developed for our high-end flight preamps, and it has an internal sound card option called Synopsys. It has the Seagate supercapacitor PSU upgrade. It has a Phoenix 78 RPM option, the Neumann WV2 output option. Let's look first at the Synopsys sound card option. So the Synopsys sound card is an internal to the Flux AI, and it offers a standalone needle drop solution. It's driverless and uses class compliant USB protocol controller, which means that it works with all operating systems, Apple, iOS, Windows and Linux. It also contains something called NICE processing. NICE stands for Near Instantaneous Compatible Expansion. It's compatible with all preamplifiers and sound cards, but it works particularly well when the Flux AI preamplifier and the Synopsys sound card are used with the Stereolab app, in which case we secure 96 kHz full 118 dB dynamic range recordings of needle drops. The Seagate supercapacitor PSU upgrade. Seagate was the personification of silence in the traditions of ancient Greece, and it employs electrical double layer supercapacitors which remove any noise or interference on the incoming power supply. EDLC supercapacitors you can think of as a sort of hybrid between capacitors and batteries. The Phoenix 78 option, we have the many recording characteristics which were used during the pre-RIAA world are all available within Stereolab. In fact, we believe it's truly encyclopedic, the number of equalizations that we have. But what about if you want to listen to 78s in real time? That's the point of the Phoenix option, and the frequency response to the Phoenix option is shown in comparison with RIAA there. So much less bass boost than you get in RIAA discs, which is a good feature for almost any record made before RIAA. The Neumann WV2 output is based on the output stage of the WV2 playback equalizer for the Neumann AM32 lathe, which some people regard as the absolute holy grail of RIAA preamplifiers. It's transformer coupled and has enormous headroom. The other thing that the Flux AI has as an option is Frankenstein enhancement. To demonstrate that Flux has something for all vinylistas, we have a series of user cases in the manual, and that manual is available, by the way, on the website. We're only going to look at two extremes, if you like, in here. So the first one is the archivist. Now, so she chose to have the internal Synopsys sound card, so a single connection to her computer. She has the RIAA option, which feeds her monitoring solution. But it isn't just about needle drops. We also have another user case, the audiophile, and this guy there's no computer in sight here. So there's you have an input stage. He has the Neumann WV2 output stage feeding his sort of no compromise monitoring system, and he uses an external audiophile power supply to drive the preamplifier. So taking a quick tour at the internals of the Flux AI here. This is the functional schematic. You can see here the input here. Phantom power is optional here. This is the moving coil. Very, very low noise phoneme preamplifier there. This is the bridge and the flat preamplifier to feed the output here. That's the recording output, so the one that goes to the computer, the sound card, or indeed it can be fed to the internal sound card here. And then we have the expansion options, that's Frankenstein and Phoenix. And then this is the WV2 option, so the drive and the balance transformers there. So just looking at the component parts, that's the Synopsys sound card sitting on top there, and the EQ card, that houses the RAAA option, the Phoenix extension, and the Frankenstein. The Neumann transformers are there, and the input option sits underneath the sound card if it's fitted, but it fits on a lower deck. Here's a brief look at the options, so you can see that you have the various input options here. So moving coil, very high gain moving coil, flux, strain gauge, isobridge, that's the bridge option, and displacement for flux 3 displacement cartridges. And then here are the expansion options, so the synopsis, the internal sound card, Seagate PSU, upgrade, RAAA, flux Neumann WV2, Phoenix, and the Frankenstein. So there we are. We've looked today at the Flux AI and Groove Sleuth solution, and seen how they operate with the new version 4 from Stereolab. And don't forget that Phaedrus and spatial listening rooms, which are available on the respective websites, where you can listen and compare preamplifiers and listen to the results of the signal processing in Stereolab.